This lesson is over line plots, bar graphs, and histograms. So the majority of this is actually review material, but the thing we'll talk about at the end, histograms, is a little bit new. So first of all, we're going to use this table to create a line plot on the number line. Remember, a line plot is a diagram that shows the frequency, how often something occurs, of data on a number line. So for 40, we're going to make a little x over 40. And then for 38, we're going to make a little x over 38. Next one is a 40 and a 37, a 33, and a 23. And notice how I'm trying to make all of my little x's the exact same size. That way, when you look at it, it's really easy to compare how high up everything is on the graph. So 16 and 30. 20 and 24, 21 and 17, 20 and 19, bless me, sorry, 14 and 10, and 13. So here's 14, 13, and 10. So when we look at this information, the easiest thing that we can tell from this information is our mode. In this case, there are two, both 19 and 20. And we can also tell the range pretty easily from this type of representation. 40 minus 10 is 30. So these are all 30 units apart. So there's some other information that you can figure out from these. You can look at clusters. So the majority of your data in this particular line plot appears to be right here. Again, it's very easy to tell your range. And then in this particular circumstance, notice how your lowest value, your lowest extreme, is very far away from your next set. So there's a pretty big gap there. And there's a pretty big gap here. So we call these, when there's one that's just randomly over here, we call those outliers. And it's because they're quite separated from the rest of the data. Oops, wrong direction. All right, so we're going to list the data shown in the line plot from least to greatest, and then we're going to identify the mode and the range. Well, the mode is 10, and the range is 20 minus 4, which is 16. So again, those are the two easiest pieces of information to tell from this type of representation. And then it's also fairly easy to list these values from least to greatest when they're written this way. So we have a 4, we have 2 6s, we have a 7, 3 8s, 2 9s, 4 10s, 3 11s, 2 12s, and we also have a 20. So notice this 20 is really far away from the rest of this cluster. That's called an outlier. A bar graph is another way of representing data, and it's used with solid bars to represent our quantities. So this table shows our top speeds of 4 different animals. We're going to use this information to complete the bar graph. So a cheetah is at 70, so I'm going to make a bar. And it's easier to do this on your paper. It's kind of hard to draw it neatly where I'm doing it from. And so I usually write the number on top just in case my handwriting's not so great. It's probably a good idea for you guys as well. The wildebeest is at a 50. So you can see mine's not exactly on the line. So I'm going to write a 50 over here so everybody knows what I'm talking about. The lion is also at a 50. That one's drawn a little bit better, but I'm still going to label it. Then we have 45, so 45 is going to be halfway in between there. And notice these bars are separated. They're not touching each other. That's going to be important in a little bit. And then the last one is 40. So in this particular circumstance, a bar graph is better than a line plot for representing this particular data, because that would be a lot of x's over the number 70. Additionally, this information is listed using two different pieces, a cheetah and the speed. All a line graph does is show you numbers. So you would lose the number of the labels on those animals, and so it wouldn't be as meaningful to display that data because all you would see is a whole bunch of X's over the value of 70. So the next one says the bar graph shows the monthly number of tornadoes that occurred in the U.S. in 2004. Which season had the least number of tornadoes? So this is the number of tornadoes for January, for February, and for March and April, May, et cetera, et cetera. So which season had the least number of tornadoes? Well, we have winter, spring, oops, my values are a little bit off there. So summer is June, July, and August. So this would be fall. And then winter would be over here. And then spring is right here. So which one had the lowest amount total? That would still be winter. A special kind of bar graph called a histogram uses bars to represent the frequency of numerical data that have been organized in intervals. So this histogram was created from this table. So what this allows you to do is see a range of data grouped together and how often something appeared in that range. For instance, if we're looking at this, animals' top speeds, so animals that ran from 11 to 20 miles per hour, there were 5 of them. 21 to 30, there are also 5 of those. 31 to 40, there's 10 of those. So what that allows us to do is look at more of a range, which is sometimes more meaningful. You might have one animal that runs 31, and you might have 6 that run 35, and it's going to be more meaningful to look at those in this particular circumstance as a group instead of as separate individual little speeds, because otherwise you'd basically never get done. So what we're looking at here is 11 to 20, our graph reaches up to 5. 21 to 30, our graph also reaches up to 5. 31 to 40, it reaches up to 10, and so on. Notice at 51 through 60, there were just no animals in that category, so there's no bars. The other thing to notice is these intervals are what we call mutually exclusive, meaning that it goes from 11 to 20 and then 21 to 30. There's no overlap, because otherwise, if this was 10 to 20 and 20 to 30, if you add a 20, where would you put it? So they have to be mutually exclusive. So the similarities that you may notice between these graphs, between this and a bar graph, is that they both use bars. They both have labels on X and Y. So there's 2 axes. So basically they're looking at the frequency versus some sort of category, which is similar to a bar graph, except it's not really called a frequency, but sometimes it's still those numbers compared to these labels. So what kind of differences do we know? Well, the bars touch. That's the main one. And the second most important one is that it uses intervals. So typically on a bar graph, down here, you're going to have categories. See, this has categories like months, or this one had animals. These are the histograms are going to have frequencies here. So, intervals. So intervals and bars touching is the main thing. The other thing is that they do start at 0. So they go from 0 in numerical order. But these are the main 2 that you're going to need to know. So looking at this one, we have magnitudes of the largest U.S. earthquakes, and they're organized into this frequency table. So we're going to display this data. So this frequency table, I've got 1, 2, 3, or I've got 1, 2, 4, 5, and 14. So I only have to go up to 14 here. So I'm probably going to just go ahead and count by 2s. be a little messy because I'm creating it myself, but you could use a ruler to help you out with this process. And please remember, we are going to label all the way up. And I did say a minute ago that they start at 0, but they don't have to. Like in this particular case, we've got 7.0 to 7.4. That's going to be my first bar. And then 7.5 to 7.9 is going to be my second bar. And then 8.0 to 8.4. You always want to try to see how I'm spacing them out pretty evenly. They represent the same spread of information, so you're going to want to try to put them as close to even as possible. Okay, so on that first one, I need to draw my bar up to 4. And this is one of those situations where I also number at the top. And then I'm going to draw up to 14. And then I'm going to draw off to 5, 2, and 1. Notice that they touch. They're all even. I've labeled them above. Please make sure to also label your axes. This is your frequency, and this is your magnitude. So the next example shows a histogram that's already completed. And what we're looking at is for how many moles are represented in the histogram. So this is the number of stores, and this was the frequency of the time that it occurs. This one's a little tricky because what it's saying is that we have 10 moles. Sorry, my board's disconnected. We've got 10 moles that have this many stores. And we have 14 malls that have this many stores. We have 4 malls that have that many stores. There's one mall that has that many stores and one mall that has that many stores. So how many malls total? We have 10 plus 14 plus 4 plus 1 plus 1. So 10, 24, 28, 29, that's 30 malls total. How many malls have less than 200 stores? Just those 10, because that's 125 to 199. How many malls have 200 or more? That would be all the rest of these numbers, so 20. All right, complete the next few pages in your booklet and have them ready to check tomorrow.